Good evening, students. Today we are going to learn the topic mass and weight. What is the difference between mass and weight? Most commonly, we are using the term called weight for measuring the mass of vegetable. So that is the wrong term. So basically, what is the weight? That we will understand. A student, we are knowing that if there is two mass m1 and m2, then they are attracting each other with a force given by F equals to g m1 m2 by r square. So this force is in two mass, there is always force of attraction. Now when the force is acting, from the Newton's second law, we have learned that this force always produces acceleration A, and that acceleration is given by force divided by the mass. So the term mass again and again we are using. If we consider one of the mass as Earth, then this force of gravitation is called force of gravity. And because of this force of gravity or earth pull, the acceleration produced is denoted by g and given the name acceleration due to gravity. So this is other important formula of this chapter. Now what is this g, this f? This we have to understand in more detail with reference to this mass and weight. A student, in this formula we have used one term called mass. So the term used mass is a scalar quantity which simply tells how much material is there. But the weight is earth pull. Weight is earth pull, means this pull or push is called as what? Force. Means weight is a kind of force. Means the force with which a mass is attracted by the earth is called weight. It's so simple. So there is a broader or vital difference between mass and weight. So a student, we have to keep in mind mass is a scalar quantity. Right here it is a scalar quantity which tells us the amount of material present in a body. Say if you are taking a corket ball, you are getting that it has certain mass or it can put certain impact. But of the same size, if you are taking the iron ball, then you will get, oh, it is quite heavier. Then what we say, the mass of corket ball and mass of iron ball are different because the matter is different. So mass simply tells the matter, how much matter is present inside a body. So how much matter is present? It do not have any direction, therefore it is a scalar. So right, mass is the amount of matter. But so it is finally written as amount of matter present or contained in a body. Present or contained in a body. So it is just how much matter is there. That is how much matter is there. That is present in a particular body. In a body. If the body contain more matter, means its mass will be more. But if we consider the weight, weight is a different kind of thing. Weight is what? It is the earth pull. So earth pull or push is called force. Force about direction. Therefore, this weight is a vector quantity. So it is a vector quantity. Now this vector quantity is what? This vector quantity is nothing but a particular kind of force. So therefore, this is our earth pull, means the force with which earth is pulling an object toward itself is called weight. Okay, so let student please be on time. So weight is a vector quantity. It is earth pull. The term earth pull is representing the force exerted by earth over the object. So as a result of this earth pull, the object fall toward the earth. So it is earth pull means it is a force. So the complete definition of weight is like this. It is the force with which a mass is attracted by a body. Sorry, mass is attracted by the earth. It is the force with which a mass is attracted by earth. So we have to keep in mind it is a force. Which kind of force? Force of attraction by the earth. So it is simply the earth pull. So it is a vector quantity. But the mass is not a force. Mass is simply how much matter is present. Now, if more matter is there, it means more mass, more the volume occupies if the density is lesser. A student, so mass is simply the matter present. Say if I am considering this pen, so how much matter is present in this? That will called as mass. But if I leave it, it will fall toward the earth. Then how much force is acting over this matter or this pen? That will represent its weight. Means each mass possesses weight. If there is any matter, then mass cannot be zero. So whatever the matter you are considering, it must have some mass. That was the definition of your matter. So right, mass can never be zero. So right, it is, all right, it can never be zero. Means if the matter is there, obviously it must possess mass. Wherever you go, whether you take this pen from this earth's surface to moon or in a satellite, its matter present in this pen will always remains the same. It will not change. So it can never be zero. It never changes from planet to planet or space. So it never changes from place to place, from one place to another, or one planet to another, or from earth to space. So this is simply the mass simply means how much matter is there, it will remain as it is. But weight is not simply this matter present. So weight is force with which it is attracted by earth. And we have learned that this force is given by, if we consider the earth mass m, capital M basically, then the force exerted by earth over the small mass m is given by gmm by r square. But the weight is given a specific symbol called W. Why? Because this capital G M by a small r square, it represents a small g, and this mass m itself is the small m. So this weight is nothing but the force with which the earth is attracting any object toward itself. So this weight is given by m into g. Means weight depends on mass, but mass do not depends on weight. So right, weight depends on mass of a body. First is mass of a body, and the next factor is the gravitational pull or gravity. It is given in the term of acceleration due to gravity. So weight depends on mass of the body and acceleration due to gravity. So therefore, this weight W is written as mass m into acceleration due to gravity g. So mass of a body is denoted by m and acceleration due to gravity is denoted by g. So where in this formula this m represent mass of the body and the small g denotes the acceleration due to gravity. And the term W or the symbol W denotes the weight of the body, weight of the mass m or body. Means each and every mass have certain weight, and that weight do not only depend on the mass but also depends on the acceleration due to gravity. So right, every mass have weight provided acceleration due to gravity exists. So if there is acceleration due to gravity, then the body have mass. How is this? Because the weight is given by mass into acceleration due to gravity g. Say if we consider on earth, then the value of g is given by 10 or 9.8. So right, on earth this g is exact value is 9.8 meter per second square, or approximately taken as 10 meter per second square. Therefore, mass of the body m have the weight which will be 10 times of its mass. Therefore, on earth the weight is given by m into g, m into 10. I am just considering this value for convenience. So it is our 10 m. So weight of a body on earth is how many times? 10 times its mass. This you have to keep in mind, student. So the body have mass, then it have the weight which is obtained by multiplying the mass by 10. Say my mass is 60 kg, then my weight will be 60 into 10, it becomes 600 Newton. Okay, student? So this weight is a force. So therefore its unit will be Newton. So we have to write more. So let us continue to write. So we are writing for the mass on left hand side and weight on right hand side. So here we have observed that weight of a body on earth is given by 10 m. Okay, the unit will be Newton. If we consider on moon, last time we have learned that g acceleration due to gravity on moon is 1/6 the acceleration due to gravity on earth. Means this is our 1/6 into 10 we may write. It was 1.6 approximately meter per second square. Therefore, for the same mass m, the weight on moon is how much? So it will be our mass into acceleration due to gravity at moon we need to consider. So it is our m into, we may put 1.6 this much. So it is simply 1.6 of m. Means what? A student, understand this carefully. If I consider this pen, it have mass m, then its weight on this earth surface is given by 10 into its mass. But if I take this pen to moon, then the weight at moon will be only 1.6 into its mass. Are we getting? So this way we are observing that weight varies from place to place, planet to planet. It is also possible if acceleration due to gravity g is 0 at somewhere, then its weight can be 0. So that condition is called weightlessness. So a student, from here we can observe that we may consider the weight of the object on earth means 10m as equation 1, and weight of the same mass on moon as equation 2. So here we can observe that weight of the body on moon by weight of the body on earth is given by how much? 10, no, 1.6 that we have taken, m divided by 10m. Again the same thing, 1.6 m is what? 1 by 6 of 10. So mm will get cancelled. It is like our approximately 16 by 100 you may consider, or approximately it is nothing but 1 by 6. So therefore weight on moon is just 1/6 the weight of body on earth. This is the other thing that we have to keep in mind. So this way we are observing that weight varies or depends on the acceleration due to gravity g. So if g is equals to 0, where this g becomes 0, so there are certain situations like in a space. If you go in a space where there is no acceleration due to gravity or no force of attraction between the earth or any other planet, so in satellite, or in space, we cannot observe the acceleration due to gravity g, then g is 0. So in space the value of acceleration due to gravity is 0, exclusively in satellite which is rotating around the earth. The other, also at the center of earth, if you reach to the center of earth, earth is our like a sphere, it must have some center. So at this center the acceleration due to gravity value is 0. So z is equals to 0 at center. So the second situation means the acceleration due to gravity g becomes 0 at center of earth. Keep in mind, student, this center is inside the earth's surface where we cannot reach practically. It is quite difficult, but by experiment it is determined. So if the g value is 0, then its weight will also be 0. So therefore this weight is equals to, though the body have mass but there is no acceleration due to gravity, so in such situation m into 0, anything multiplied by 0 is always 0. So this implies weight could be 0, where at earth center And the other situation is our satellite, means the in satellites. So weight can be 0, but mass can never be 0, student. So write down the point. So weight can be 0, but mass can never be 0. That we have to keep in mind. Because mass is what? Mass is simply the amount of matter. Whether I am taking this pen on Earth's surface or on the moon, it always remain as pen and it will occupy this much space. So write this. Important. So it never changes from place to place. It can never be 0. Yeah, it is already written above. It can never be 0. So it is important thing that we have to keep in mind, or we shall write like this. Mass can never be 0. So write down a note here. Mass can never be 0, but weight can be 0. But weight can be 0. So this is the important point that we have learned. Why the weight can be 0? Because weight is given by mass into acceleration due to gravity. So if G is equals to 0, this implies W is equals, means the weight is equals to 0. So this I had explained. Okay. Now coming to the other thing, coming to the unit. So unit of mass is kg. Good. So whatever the quantity that we have started in physics, say kg, meter, second, the mass, distance and time, that was the basic quantity. So the same mass we are discussing here. So this mass can never be 0 and it is always measured in kg. So this we have to keep in mind. So its value is in kg. But the unit of weight is, so what is this word?
Newton.
Very good. So here we are getting that mass into acceleration. G is a kind of acceleration. So its unit is Newton. Student, it is very important point that we have to keep in mind. These two are very important point. Question are asked. Write in bracket, it is our Newton. N denotes Newton. Why? As it is a force. As it is force. You may remember like earth pull. Any pull or push is called as force. So the unit of weight is our Newton. This is the other point that we have to keep in mind. Other thing we had already written. Mass is a scalar quantity, but weight is a vector quantity. A student, we had learned the term called inertia. Okay, inertia is what? How much is the tendency of a body to maintain its state? If it is at rest, it will try to maintain its rest. If it is in motion, it will try to remain in motion. A student, you have observed it is easy to push a ball at rest. But if there is a big stone in your playground, then you cannot push it. What What is the difference? It is the mass. Mass of a stone is much more than the mass of ball. Therefore, the tendency to maintain its state for the bigger stone or bigger mass is more. Means higher the mass, more the inertia. Okay? So tendency to maintain its state is called inertia. So right? So mass gives inertia. Whatever the inertia that we had learned in Newton's first law of motion, the same inertia I am talking. So state, maintain its state. So maintain its previous state. This state may be your state of rest or a state of motion. So more the mass, more the tendency to remain in rest. Even this is also true for a moving body. You are observing that if the bicycle is coming with certain speed, you can stop it with your hand. But with the same speed, if the bus or car is coming, can you stop it? No. Why? Because its mass is more, it has more tendency to maintain its speed. Getting? So mass gives inertia. More the mass, more the inertia. More the inertia. This is very important. So mass is measure of inertia. This we have to keep in mind. So mass is measure of inertia of a body. Means how the body will try to maintain its state of rest or motion. But what the weight gives? Yes, student. But weight is measure of what is this? What the weight gives? Weight is the measure of earth pull, student. Okay, or measure of the force exerted by the earth over the object. So measure of earth pull. We are considering the object on earth, therefore we are considering the earth pull. If we are going on moon, then the pull of moon. So this is the other important thing that we need to keep in mind about the mass and weight. So mass is measure of inertia. Mass is given by Newton's first law, but weight is given by Newton's second law. You may also rewrite like this: mass from means mass is what? Inertia. This we have learned. Newton's first law gives inertia. Newton's first law. But weight is what? A kind of earth pull, or it is basically a kind of force. So is obtained from Newton's second law. So these are the things that we have to keep in mind. Okay. Now coming to the measurement. You are going to the vegetable shop and you are asking for 1 kg of potato. Which kind of device the shopkeeper is using? He is using a plain balance where he is placing 1 kg on one of the pan and 1 kg of vegetable on the other side of the pan. So this balancing Means this balancing indicated by either pointer in between or a digital meter in between. So this balancing is called simple balance. So right, it is measured by plane balance. So it is measured by balance or plane balance or plane balance. Means it is like this. That you people have learned in your earlier standard. So take the two pan, put it, and you at the center you take a pivot. If it is exactly horizontal, then whatever the 1 kg what you are putting and whatever the material you are taking, they are considered equal. Okay, the unit that we are taking, then this material is also 1 kg. Correct? It is like this. So simple balance or plane balance is it. But how the weight is measured? For measurement of weight, we are also observing in some of the cases, say for cylinder or in many other objects, there is certain spring like thing in which the spring is fixed as certain ceiling and the object is hanged in that the hook of that spring, and the spring comes down, and over the scale you will observe the pointer is coming down. So that kind of measurement is called
Spring balance.
balance. Good. So weight is measured by spring balance. Good. So it means it is the mass, student, right? In first, these are very important things, student. Weight is measured by spring balance. Which, so this spring balance measures the earth pull. Measures earth pull. How? Student, you may just understand. Let us consider a spring under normal situation is like this one. I may consider a spring in normal situation in coiled form. It is like this one. Means it is up to this much coiled. Now this end is connected with a hook. Hook is there. Now fix the other end over a ceiling. Means it is the fixed support. It is fixed support. So this is the normal condition. Now this spring may be fixed with another pointer or a small wire which is just projected outward or fixed at this end, or at this end we can measure. Better to put it at the last end so all stretching can be observed. See, student, at this end means last end, we can fix it with a small pointer. So this is the pointer. Now under this normal condition, this spring is being packed like this. So this hook I shall take a bit bigger so that you can understand. So it is like this one. Here the hook is connected. So under normal condition, you are observing this spring is up to this much situation. So this is the packing of or outer box of this spring balance. Now, if you hang any mass in this, means if you are hanging another mass here, M, because of this mass, the earth will try to pull it downward. It will experience a force weight given by M into G. As a result, this mass will get stretched and all this spring will now come like this. So this could be the new situation. Means this pointer will now come at this point. So this was the earlier older position of pointer. Now the pointer is being stretched and it have reached to the new position. So how much is the stretching? This much stretching. If more mass is there, this stretching will further down. Okay, the pointer will further move down. Therefore, this scale means this is marked with a scale. So this you may take this as 0 and say this spring can be stretched up to 20 kg, then up to 20 kg of mass can be hanged here and it can stretched up to this much. So 20 kg. Corresponding to this 20 kg, the weight 20 into 10 means 200 Newton it will measure. So this 20 kg is identical to 200 Newton. Okay? Because of this acceleration due to gravity. There is another way of making this machine. The other way, the spring itself is nowadays, whatever the rice and the things that you are purchasing, so this spring is kept below with certain, arrangement. So this is the spring arrangement. Now this is the pan. Now this is spring, corresponding to this spring, a meter is connected here for the display of the digit. If you are placing any mass here, obviously this spring will get compressed. So this is the method of compressing a spring. Compressed means the size will shrink. Compressed spring. So by compression, because of this mass M, the weight W is equals to mg will act over this spring, it will get compressed. How much is compression? That is measured by here the meter. So this is the indicator or digital meter. So this indicator will give you the air reading. So nowadays in shop, this method of compression is used for giving the mass or even the weight. So we have to keep in mind, weight is a force, it is measured by spring balance, but mass is simply the inertia, it is given by plane balance. So these things we have to keep in mind. So this was all about mass and weight. The mass can never be 0, but weight can be 0. Mass is a scalar quantity, but weight is a vector quantity. Okay, students, so we shall keep in mind or number 8. Very first, mass is a scalar, but weight is vector. This one. The definition is like this. Mass is how much matter is there, but weight is the earth pull or the force with which earth is attracting the object. So this is the definition that we have to keep in mind. This weight depends on acceleration due to gravity. G So if the g is 0, it can be 0. Okay, so it is this acceleration due to gravity, it can be 0. But mass is the matter content, so it can never be 0. So the third point is this one. Mass do not depends on any factor like acceleration due to gravity. Though the weight depends on mass, but mass do not depends on weight. So you may write like this: mass do not depends on weight. On weight, because weight is a vector quantity. The weight itself is depending on the mass. So this is the fourth thing that we need to keep in mind. So comparing this, mass can never be 0, but weight can be 0. This was the another important note that we had written. Regarding unit, the fifth thing we had written, unit of mass is kg, but unit of weight is Newton. This we have to keep in mind. Coming to the next point, sixth point. Mass is measure of inertia, but weight is the measure of earth pull. So it is this one that we need to keep in mind. Mass is obtained from Newton's first law, weight is obtained from Newton's second law. The another seventh important difference, mass is measured by plane balance, but weight is measured by spring balance. Okay, these are the other thing that we need. When the weight can be 0 or where the weight is 0, so weight is 0 when acceleration due to gravity is 0, and it is 0 at center of earth and in satellite. So such a situation when the weight is 0, it is called as weightlessness. Means weight is reduced. So weightlessness. More detail you will learn in higher study. Okay. So this was all about our mass and weight. A student, questions are asked. The questions are very simple. So that you just do one of the question based on mass and weight. So let me frame a small question. So write 5 kg mass is sent from earth to moon. Okay, then find the very first you have to determine weight of object on earth, of that mass on earth, and second, the same thing, the weight of that mass on moon, that we want to know. Okay, student. So the question is very simple. Here it is given that 5 kg is there. So mass is equals to 5 kg. It remains 5 kg whether it is on earth or on moon. So mass always 5 kg. So it's always, whether it is even at earth and at moon. So mass is always 5 kg. Mass will never change, but weight on earth, so weight on earth is given by m into z, so it becomes 5 into on earth, it is 10. I may take, so it is our 50. How much? 50 kg? No, student, the unit is Newton. This we have to keep in mind. But for the same object, the weight on moon, how much is the weight? So the mass remains the same. Now the g of moon we need to take. Earlier we had taken g of earth. So to make difference, use the suffix w moon and w earth for weight at earth. So w moon is given by the mass remains the 5, but g become 1.6, so it become 8 Newton. So this much we are getting. So this much is the difference. Question may be asked. The other question, what is weight of 10 kg or say 25 kg mass at the center of earth? Means if the 25 kg mass is sent to the center of earth, what will be its weight, student? Yes, student, tell me. Give the reply. At center of earth, what will be?
0.
Very good. At center of earth, g is equals to 0. The acceleration due to gravity is 0. Therefore, weight
Is equal to 0.
very good. So this will be 25 into 0. Anything multiplied by 0 is 0. So this implies answer is your 0. Okay, this is the thing that we need to keep in. So this was all about our mass and weight. So these were the differences that you must keep in mind. So they are very important, student. Mass and weight is very important, and these two questions are equally important. Now let us go for the kinetic equation or acceleration due to gravity based question. So for that I have selected some of the question. So let us do that. Or we may write, or we may recall the equation first. Just let us quickly recall. Students, we have learned that if the body is in the free fall motion, means the body is falling under the influence of earth only. So free fall motion means the mass m, forget about the mass, whatever the mass is there, this is the earth. So if the body is falling down or moving up, it is always acted by the acceleration due to gravity because of the earth. Okay, in this case we have the three important equation. So speed at any time t depends on its initial speed u. So v is equals to u plus at, so it becomes u plus gt. H, the height is denoted by h here. So in this case, this is the h we are denoting rather than s, is ut plus half gt square. and v square is equals to u square plus 2gh. So here we have to keep in mind this positive sign of g is taken means it is moving for downward motion. Good, means the body is moving downward, that's why g is taken as positive. If the body is thrown upward, then g have to be taken as negative. So in this case, the sign between these equation get changed. So let us write for the upward motion. For the upward motion, the same equation, but only the sign have to be changed. So right, in this case, v is equals to u minus gt, h is equals to ut minus half gt square, and v square is equals to u square minus 2gh when if the body is moving upward. So that's why g is negative. G is taken here. Okay, so these are the things. But my advice is you just keep one of the equation set with the positive sign in your mind, and if the body is moving upward, then take g as negative. No need to mug up this with this equation with the negative sign. Another thing that we have learned, u could be 0 if the body released from rest. If it is released or started from rest. Finally, this v can also be 0 if come to rest. Come to rest or finally stop. When this can happen, we have learned if the body is thrown upward, then at the top point when it is going to change its direction, the v is 0. This we have learned in our chapter 1. So at top of the journey of a body, its final speed become 0. So these are the things that we need to keep in mind. Now applying this kinetic equation and this concept, the questions are framed and they are asked. So how is this? We have to solve few questions. Student, these questions are very easy. We have to keep in mind. So let me explain these questions. So here I have to solve these two questions. Student, let us come to the 10.3. In numerical, we have to note down the given condition and what is required that equation. So an object is thrown vertically upward. Here you have to mind it. Roughly first draw the diagram. So I can draw the diagram like this. The body is thrown upward. So take just a mass or any object. No need to take the mass here, but just draw the symbol of the body. It is thrown upward. For throwing a body upward, see, I'm just keeping the pen on my hand. Can it move upward automatically? No, unless or until I give an upward jerk or the upward speed or upward velocity, it will not move. So for throwing a body upward, we always must have some initial velocity u. Okay? Now, while it is thrown upward and continue to move upward, you are observing everything return after some time. Why? Because of the earth pull. The earth is always exerting an acceleration downward. Because of the earth pull or force, the acceleration g is there, which is always acting downward. So g in this case, we must keep in mind g is always, let us take this g value as 10 meter per second square. It is our downward. These things we need to keep in mind. So because of this downward acceleration and upward initial speed or initial velocity, the body will finally come to rest somewhere. Means at the top, its final velocity become 0. Then after this velocity becomes 0, it will momentarily come to rest at the top of its journey, then again start falling downward. Then it will turn downward. Okay, so this is the journey of a vertical motion. So what are the data given? So an object is thrown vertically upward and raised to a height of, it is given that the body have traveled a height h. You can write over this figure itself 10 meter. Calculate the velocity with which the object was thrown upward. Means what was its initial speed, that we want to know. So student, what is given here? So it is able to reach up to height of 10 meter. Means before returning back, it have moved to a height of 10 meter. From its starting point, it have reached to a height of 10 meter. Okay, so here at the top of its journey, the final velocity is 0, then it will return back. So with help of this, final speed v is equals to 0 at top of its journey, you can be calculated. The second part, the time taken to reach at the highest point. So I may consider this was the initial time t is equals to 0 and it reaches at t. So this t is equals to how much? So student, we have to write now at top of journey, top of or highest point or highest point when it start returning, when it starts returning, its final velocity v is equals to 0. Now since write down the formula, what is applicable? Means we have this situation is like this. Initial velocity that we need to calculate, finally it is able to reach to certain height h. So what is the formula which is relating this u v?
That is u square minus.
Very good. Student, since the body is under the free fall or under gravity, so there is always g which is known to us. So g is always there. So its value is 10 meter per second square. Now since v square is equals to u square plus 2gh, now we have to substitute the formula or the value of u, v, h and g in this formula with proper sign. Sign is very important. A student, when the body is thrown upward, we can take upward direction as positive, but the g is acting downward, then g can be taken as negative. Okay, so when the body is in upward motion, we are mostly replacing this positive sign by the negative sign that we have already learned. So it is upward motion, so I shall use z as negative. So g 10 meter per second for downward. but this g value is minus 10 meter per second square for upward. Here, what is the situation? The situation is for the upward motion. So I shall take with negative value. So this is the important thing that in such a question you have to keep in mind. So when which one is positive, which one is negative, accordingly you have to substitute. So just substitute it. Final velocity v is 0 is equals to u. We want to calculate u square. Now plus 2, this is our minus 10 into h we want to calculate. No, h is already given to us. How much is h? It is given here. Student?
10.
Yes. So 10. So it becomes 0 is equals to u square. Take this minus outside. 2 into 10 into 10. It means it becomes 200. Can we write like this? Surely we can write. So bring this u square on this side, or 200 on left hand side. Bring this on this side. So 200 become positive is equals to u square. So lastly, for calculating the u square, you need to put a square root there. A square root of 200. So 100 can be taken out. It is like our 2 into 10 into 10. So it is 10 root 2 unit is meter per second. We may substitute the value 10 into 1.42. So approximately it is 14.2 meter per second. So this was the speed with which the object was thrown upward. Okay, student? It was this one. Now, here it is also asked the time. So at the while reaching to top, how much time it is taking? That t we also need to calculate. So right, for the second part, since v is also given by u plus zt at the top. So at top, v is equals to 0, but u we have just calculated. It was, or it is our 14.2. We may put 14.2 meter per second. It is calculated. This we need to use it here. So therefore, substitute all these things. G is already minus 10 meter per second square. Substitute it here. 0 is equals to u is our 14.2 plus of minus 10, means I can directly write at this as the minus of 10 into t. So bring this 14.2 on left hand side, or bring this negative 10 t on left hand side. A student, bring this. So 10 of t is equals to, so write it, 14.2. So t is equals to 14.2 by 10. So t is equals to 1.42 second. So this is the other time required. Okay. So the questions are very easy. You need to practice a bit more. While practicing, you can get it. Student, the same or exactly same one is the question number 15 we have taken from our exercise. So, but in this question number 15, we are given with vertically upward with initial velocity. See, the u is already given here. So in this case, u is given as 40 meter per second. G is already known to us. It is upward. So again, we have to take this z is equals to minus 10 meter per second square then you have to find the maximum height h it can reach. Student, again we need to apply the same thing. At the top, v is equals to 0, applying v square is equals to u square plus 2 gh. In this case, this g is negative, so we can directly use this minus z. Now this v is going to be 0, so this implies 0 is equals to u square minus 2gh. So h can be directly calculated by bringing this u on left hand side, u square by 2g. So even substituting in this, h is equals to u square by 2g, we can get it. Okay, or this is also asked in MCQs. Say a body is thrown upward with speed u, then what is the maximum height raised? The maximum height raised is given by u square by 2z. So this is sometimes also used as formula. So substituting here, u is given, it is about 40 square by 2 into 10. So it becomes 40 into 40. So 40 into 40 by 2 into 10 is our 20. So one of these 40 can be cancelled 2 times. So it becomes 80 meter. Are we getting? So this is the final answer. This way you can calculate. So questions are very easy, student. What is the displacement? Obviously, this much is the only displacement while it is moving upward. But while it will fall down back, then displacement is equals to 0. So what is the net displacement and total distance covered? The question is, while the object is again coming back, so displacement is 0 and total distance, once h in forward direction, then also returning from the same height, distance is given by twice of h. So distance is given by twice into 80, so it is 160 meter, while the displacement is 0 if we consider the object have returned back to the earth. Find the maximum height reached. Maximum height is our 80 by the stone. What is the net displacement and total distance covered by the stone? So see, the stone cannot hang at the top of their journey. So net, it is asked for net, means obviously the stone will come down and it will finally fall to the ground from where it was sent. So the net displacement we have to say as 0 because the body have returned back to its original or a starting point, and the distance is twice of the total height. Okay, student? So it was all about this class. Other question you please do, because our time is up. So next day, I mean tomorrow, if you have any doubt in this chapter, then please ask. Otherwise, we will start with the new chapter of mathematics or biology. So that we will decide later. So a student must note down your homework. A student, do the homework. Our textbook questions means exercise questions, and there are two kind of question. One is called as the blue question, another one is our exercise question. So blue question, this exercise question up to 18 you can do. I hope up to 6 or 7 we had already done. So up to 18 you have to finish. This buoyancy is not required. And here so this is based on the weight and mass 138. One is on the, another one is on 136, So blue question on page 136 and 138, and exercise question up to question number 18. Okay student, please do this homework, then we will meet tomorrow. Yes student, any doubt then please ask.
No doubt, sir.
Yes, please do not forget to finish your homework. So I have also posted your
Okay.
homework in your WhatsApp.